Repairing a disk with damaged LVM headers and metadata using the pv create and the vgcfg restore commands. You can restore metadata and headers on a physical volume that is either corrupted or replaced with a new device. You might be able to recover the data from the physical volume by rewriting the metadata area on the physical volume. You can restore metadata and headers on a physical volume that is either corrupted or replaced with a new device. You might be able to recover the data from the physical volume by rewriting the metadata area of the physical volume. Warning: these instructions should be used with extreme caution and only if you are familiar with the implications of each command, the current layout of the volumes, the layout that you need to achieve, and the contents of the backup metadata file. These commands have the potential to corrupt data, and as such it is recommended that you contact Red Global Support Services for assistance in troubleshooting. Prerequisites: you have identified the metadata of the missing physical volume. For details, see finding the metadata of a missing LVM physical volume. Collect the information needed for the PV create and VGCFG restore commands. You can collect the information about your disk and UUID by running the previous-o plus UUID command. Metadata-file previous-o UUID, so it will display all the UUIDs of the physical volume. UUIDs of the physical volume. PVS-O plus UUID gives the UUID of the physical volume. Metadata file is the part to the most recent metadata backup file for the VG. For example, etc LVM backup VG name. Metadata file is the part to the most recent metadata backup file for the VG name. Collect the following information needed for the PV create and VGCFG restore commands. You can collect the information about your disk and UUID by running the previous-o plus UUID command. Metadata file is the path of the most recent metadata backup file for the VG. Most recent metadata backup file for the VG, for example, etc LVM backup VG name. Change directory to etc LVM backup. Say want to restore metadata of the wall group. So this is the metadata file. VG name is the name of the VG that has the damaged or missing PV. VG name is the name of the volume group that has the damaged or missing PV. UUID of the PV that was damaged on this device is the value taken from the output of hash PV S-A plus UUID. UUID of the device. UUID of the physical volume. So in the volume group, vol group slash save slash htbo, suppose I want to, I'll take the UUID of slash save slash htbo. UUID of the PV that was damaged on this device is the value taken from the output of hash PVID-O plus UUID. Disk is the name of the disk where the PV is supposed to be. For example, slash save slash HTB. Be certain that this is the correct disk or seek help, otherwise following these steps may lead to data loss. Recreate LVM headers on the disk. Recreate LVM headers on the disk. PV. So PV seek -f dump space header space disk slash save slash SDT is the disk which I have selected. VG restore the VG metadata on the disk. VG CFG restore. VG CFG restore file metadata file vol group volume group name. Do you really want to proceed with restore of volume group vol group? Well, 17 volumes are active. Yes, so restored volume group vol group. So restored volume group vol group. Optionally verify that the metadata is restored. PVC -f and dump metadata space disk. PVC -f dump metadata space disk slash save slash htt. To verify that the new physical volume is intact and the volume group is functioning correctly, check the output of the following command. To verify that the new physical volume is intact and the volume group is functioning correctly, check the output of the following command. VGS. To check that the new physical volume is intact and functioning correctly, check the output of the following command. VGS. Additional resources PVC command page. Extracting LVM metadata backups from a physical volume. How to repair metadata on physical volume online. How do I restore a volume group in Red Hat Enterprise Linux if one of the physical volumes that constitute the volume group has failed? How do I restore a volume group in Red Hat Enterprise Linux if one of the physical volumes that constitute the volume group has failed? Red Hat knowledge base. Repairing a disk with damaged LVM headers and metadata using the pvck command. This is an alternative to the repairing a disk with damaged LVM headers and metadata using the pvcreate and pgcfg restore commands. There may be cases where the pvcreate and the pgcfg restore commands do not work. This method is more targeted at the damaged disk. So this is an alternative to the repairing a disk with damaged LVM headers and metadata using the pvcreate and the pgcfg restore commands. There may be cases where the pvcreate and the pgcfg restore commands do not work. This method is more targeted at the damaged disk. This method uses a metadata input file that was extracted by pvc-dump or a backup file from etc/lvm backup. When possible, use metadata saved by pvc-dump from another PV in the same VG or from a second metadata area on the PV. For more information, see saving extracted metadata to a file. Procedure: repair the headers and metadata on the disk. pvck-repair-f metadata file space disk. pvck repair f metadata file volume groups space disk /t/stt. So writing label underscore header dot crc checksum pv underscore header uuid, writing data underscore offset mda one underscore offset mda1 underscore size mda1 underscore offset mda2 underscore size, where metadata file is a file containing the most recent metadata for the VG. This can be etc LVM backup VG name, or it can be a file containing raw metadata text from the pvc-dump metadata underscore search command output. This can be etc LVM backup VG name. This can be etc LVM backup VG name, or it can be a file containing raw metadata text from the pvc-dump metadata underscore search command output. This can be etc LVM backup VG name, or it can be a file containing raw metadata text from the pvc-dump metadata underscore search command output. Disk is the name of the disk where the PV is supposed to be, for example, /save/stb. To prevent data loss, verify that is the correct disk. If you are not certain the disk is correct, contact Red Hat support. If the metadata file is a backup file, the pvc-f repair should be run on each PV that holds metadata in VG. pvc-f metadata underscore search command output. Disk is the name of the disk where the PV is supposed to be, for example, /save/stb. To prevent data loss, verify that this is the correct disk. If you are not certain the disk is correct, contact Red Hat support. If the metadata file is a backup file, the pvc-f repair should be run on each PV that holds metadata in VG. If the metadata file is raw metadata that has been extracted from another PV, the pvc-f repair needs to be run only on the damaged PV. To check that the new physical volume is intact and the volume group is functioning correctly, check outputs of the following commands: VGS space VG name, write new LVM header to /save/stt. So VGS space VG name, vol group, PVS space PV name /save/stt, LVS space LV name, LVS log vol underscore raid1, volume group, PVC-f repair, PVC hyphen repair. Additional resources extra PVCK man page. Extracting LVM metadata backups from a physical volume. How to repair metadata on physical volume online Red Hat knowledge base. How to restore a volume group in Red Hat Enterprise Linux if one of the physical volumes that constitute the volume group has failed. Red Hat knowledge base. Troubleshooting LVM RAID. You can troubleshoot various issues with LVM RAID devices to correct data errors, recover devices, or replace failed devices. Checking data coherence in a RAID logical volume. LVM provides scrubbing support for RAID logical volumes. RAID scrubbing is the process of reading all the data and parity blocks in an array and checking to see whether they are coherent. The LV change sync action repair command initiates a background synchronization action of the array. Procedure optional. Control the rate at which a RAID logical volume is initialized by setting any one of the following options. Max recovery rate square bracket BBSS KKMMGG sets the maximum recovery rate for a RAID logical volume so that it will not expel nominal input or output operations. Min recovery rate in square bracket BBSS KKMMGG sets the minimum recovery rate for a RAID logical volume to ensure that input or output operation for sync operations achieves a minimum throughput even when heavy nominal input or output is present. LV change max recovery rate 4K my VG slash my LV. Replace 4K with the recovery rate value, which is an amount per second for each device in the array. If you provide no suffix, the options assume KB per second per device. LV change sync action repair my underscore VG slash my underscore LV. When you perform a RAID scrubbing operation, the background input or output required by these sync actions can crowd out other input or output LVM devices such as updates to volume group metadata. This might cause the other LVM operations to slow down. LV change max recovery rate 4K my underscore VG slash. So first I need to know the logical elements. LV change max recovery rate wall group slash log wall RAID 1 logical volume wall group slash log wall RAID 1 changed. Replace 4K with the recovery rate value, which is an amount per second for each device in the array. If you provide no suffix, the options assume KV per second per device. LV change sync action repair my underscore VG slash my underscore LV. LV change sync action space repair my underscore wall group slash log wall underscore raid 1. So VGC hyphen update metadata wall group. So update metadata wall group. So LV change hyphen sync action repair wall group slash log wall underscore 81. Wall group slash log wall underscore 81 state is currently repaired. LV create when you perform a rate scraping operation, the background input or output. So VGC hyphen update metadata wall group. Such as updates to volume group metadata, this might cause the other LVM operations to slow down. Note, you can also use this maximum and minimum input or output rate while creating a rate device. For example, LV create hyphen type is rate 10 hyphen I to hyphen M1 hyphen capital L 10G hyphen max recovery rate is 128 hyphen N my underscore LV my underscore VG creates a two-way rate 10 array my underscore LV which is in the volume group my underscore which with three stripes that is 10G in size with a maximum recovery rate of 128 kb per second per device. Display the number of discrepancies in the array without repairing them. Display the number of discrepancies in the array without repairing them. So I will type this LV create hyphen type. Type is raid 10 hyphen I to hyphen M space mirrors 1 hyphen capital L is hyphen max recovery rate 128 hyphen N my wall group rate 10 and the volume group is wall group insufficient suitable allocatable extents for logical volume. So I'll give only 100 MB or 50 MB. Twenty-five MB, 10 MB. Okay, logical volume my wall group rate 10 created. Logical volume my wall group rate 10 created. Display the number of discrepancies in the array without repairing them. LV change hyphen sync action check my underscore VG slash my underscore LV. LV change sync action check my underscore VG wall group slash log wall underscore raid 1. LV change hyphen sync action. So it is currently in the repair state. It is unable to switch to check. View the varlog syslog file for the kernel messages. So correct the discrepancies in the array. LV change hyphen sync action space instead of check value repair. So it's currently in the repair state. This command repairs or replaces failed devices in a RAID logical, or you can view the varlog syslog file for the kernel messages after executing this command. Cat varlog syslog. Display information about the scrubbing operation. The syslog file is not here. ls var log syslog is not in the not available in initial 9.5, or probably it is not installed DNF. What provides syslog mount hyphen t mount hyphen o loop hyphen t ISO slash RHEL on slash MNT slash disk slash red hat slash base OS or red hat ISO 9660. Now try DNF clean all DNF install DNF what provides syslog systemd or syslog. So DNF install or syslog systemd already installed. Display information about the scrubbing operation LBS -O Place rate underscore sync underscore action, comma, rate mismatch count, space, wall group slash log wall underscore raid 1, log wall underscore raid 1. So find syslog file, find slash hyphen name syslog. So var log anaconda syslog. So cat var log anaconda syslog. So replacing a failed RAID device in a logical volume. RAID is not similar to traditional LVM mirroring. In case of LVM mirroring, remove the failed devices. Otherwise, the mirrored logical volume would hang while RAID arrays continue running with failed devices for RAID levels other than RAID 1. Removing a device would mean converting to a lower RAID level, for example, from RAID 6 to RAID 5, from RAID 4 to RAID or RAID 5 to RAID 0. Instead of removing a failed device and allocating a replacement with LVM, you can replace a failed device that serves as a physical volume in a RAID logical volume by using the hyperhyphen repair argument of the LV convert command. Prerequisites: the volume group includes a physical volume that provides enough free capacity to replace the failed device. If no physical volume with enough free extents is available on the volume group, add a new sufficiently large physical volume by using the VG extent utility. View the RAID logical volume LVS hyphen hyphen all hyphen hyphen options name comma copy underscore person comma device space my underscore VG. View the RAID logical volume after the slash stage slash STC page LVS hyphen hyphen all hyphen hyphen options name comma copy underscore person comma device space my underscore VG. View replace the failed device. LV convert hyphen hyphen repair my underscore VG slash my underscore LV optionally. Option manually convert this page to a physical volume that replaces the failed device. LV convert hyphen hyphen repair my underscore VG slash my underscore LV replacement underscore PV. Examine the logical volumes with the replacement. LVS hyphen hyphen all hyphen hyphen options. Name comma copy underscore person comma devices space my underscore VG until you remove the failed device from the volume group. LVM utility still indicate that LVM cannot find the failed device. Remove the failed device from the volume group. VG reduce hyphen hyphen remove missing my underscore VG. View the available physical volumes after removing the failed device. PV scan examine the logical volume after replacing the failed device. LVS hyphen hyphen all hyphen hyphen options. Name comma copy underscore person comma devices space my underscore VG. Troubleshooting physical volume warnings from multi-pathed LVM devices. When using LVM with multi-pathed storage, LVM commands at least a volume group for logical volume might display messages such as the following. You can troubleshoot these warnings to understand why LVM displays them to hide the warnings, root cause of duplicate PV warnings when the multipath software such as device mapper multipath, DM multipath, EMC power path, device mapper multipath, EMC power path or Hitachi dynamic link manager, the HTLM manages storage devices on the system. Each part to a particular logical unit LAN is registered as a different SCSI device. The multipath software then creates a new device that maps to those individual paths. Because each LAN has multiple device nodes in the slash save directory, that point to the same underlying data. All the device nodes contain the same LVM metadata. Example device mappings in different multipath software. DM multipaths, fuzzy paths to LN, multipath device mapping to paths. DMC power path HTLM slash dev slash STB or slash dev slash STC slash dev slash mapper slash empath nor slash dev slash mapper slash empath is slash dev slash EMC power is slash dev slash STD LMAB. As a result of the multi-part device nodes, LVM tools find the same metadata multiple times and report them as duplicates. Cases of duplicate PV warnings. LVM displays the duplicate PV warnings in either of the following cases: single paths to the same device. The two devices displayed in the output are both single paths to the same device. The following example shows a duplicate PV warning in which the duplicate devices are both single paths to the same device. If you list the current DM multipath topology using the multipath-ll command, you can find both slices, STD, slices, STD under the same multipath map. These duplicate messages are only warnings and do not mean that the LVM operation is failed. Rather, they are alerting you that the LVM uses only one of the devices as a physical one and ignores others. If the messages indicate that the LVM chooses the incorrect device or if the warnings are disrupted to users, you can apply a filter. The filter configures LVM to search only for the necessary devices for physical LVM, so leave out any underlying paths to multipath devices. The result of the warnings no longer appear. Multipath maps. The two devices displayed in the output are both multipath maps. The following examples show duplicate PV warning for two devices that are both multipath maps. The device physical volumes are located on two different devices rather than on two different paths to the same device. The situation is more serious than duplicate warnings for devices that are both single paths to the same device. These warnings often mean that the machine is accessing devices that it should not access, for example, clones or mirrors. Unless you clearly know which devices you should remove from the machine, the situation might be unrecoverable. Red Hat recommends that you contact Red Hat technical support to support address this issue. Example, LVM devices filter to prevent duplicate PV warnings. The following example shows LVM device filters that avoid the duplicate physical volume warnings that are caused by multiple storage paths to a single logical unit LAN. You can configure the filter for Logical Volume Manager LVM to check metadata for all devices. Metadata includes local hard disk drive with a root volume group on it and any multipath device. Underlying paths to a multipath device such as slash C, slash STB, slash C, slash HTTP. You can avoid these duplicate PV warnings because LVM finds each unique metadata once on the multipath device itself. To accept the second partition of the first hard disk drive and any device map per DM multipath devices and reject everything else, enter filter is equal to square bracket double quote a slash a slash sta 2 dollar comma double quote a 5 slash a slash mapper slash empath dot asterisk comma double quote r5 dot asterisk to accept all HTTHP smart array controllers and any MC power devices. Enter filter is equal to double quote a 5 slash a slash c cisa slash asterisk MC power to accept any partitions on the first ID in any multi-part devices. Enter filter is equal to double quote a 5 slices slash sta asterisk double 8 slices slash number slash path asterisk r 5 dot asterisk additional resources limiting LVM device visibility and usage in the device LVM device filter.